Hello students, welcome to Sarasa classes. This is Dr. Sarkar over here and we are discussing the disconnection approach or retrosynthesis of two group CX type disconnections. And for this we are considering out here the difunctionalized compounds which are joined to the same carbon. So we will be calling this as 1,1 difunctionalized compounds. And for that we are going to use the disconnection of acetals and ketals. So what are our acetals and ketals? So when we are saying acetals means we have a R, H and a OR prime molecule for which we can disconnect over here, and this type of disconnection is called 1,1 DIX means disconnection. This is our retrosynthetic arrow. Okay, this is the retrosynthetic arrow as discussed before. So over here we are basically going to generate, after this heterolytic cleavage, a dipositive synthon, along with that a alkoxide like this, for which the reagents, if we want to generate, we will just add a proton and that will give us two molecules of alcohol. Similarly, to generate the reagent over here we will add the oxide O2 minus and that will give us our corresponding aldehyde. The similar practice can be used to find out the starting materials for a ketal, which is this, and for that too we will use 1,1 DIX, that is the cleavage happens over here. Now our synthons are this one. Besides that we have this one, and if we add the proton out here then we are having two molecules of alcohol, and if we add the oxide ion over here we have the ketone as follows. Let us apply this to disconnect a molecule which is basically a perfume, which is called as Verte de Lilas, and we are doing the analysis of this molecule, which is basically pH, CH, CH2, CH, OME, and if you are disconnecting this using 1,1 DIX, where do we disconnect? We are disconnecting over here, that is between a carbon and a heteroatom. Okay, these are called CX disconnections basically. So we are generating over here CH, pH, CH2, CH plus plus our synthon, and along with that we will be having two such alkoxide, for which if we add the proton we get the methanol starting materials. And for this one, as we did before, whenever we see CH plus plus, always remember we will add O2 minus, that will generate and give us our corresponding aldehyde. Now if we do the synthesis over here, then what we will say, pH CH to CHO, and we are basically joining the MEOH in presence of proton that coming from tosic acid, and that will give us our corresponding acetal. One should note over here an important factor, which is acetals and ketals are good protecting groups for the aldehyde and ketones. Why so? Because they are stable to nucleophiles, including the hydroxide ion, which is also a nucleophile. So let us now consider the disconnection of cyanohydrin and hydroxyamines, and let's see how we can use this 1,1 CX disconnection to achieve the starting materials. So out here again we have a RR, OH and CN. So basically if you disconnect out here, we get R plus plus R, CH plus plus R along with the OH minus and CN minus. Using the previous logic, if we add for a minus to counterbalance the charge, we'll add a proton. So over here we are having water and HCN. To counterbalance the dipositive charge, we will add oxide. So we are getting over here our corresponding ketone. Okay, so that is what we have done. Besides this, we know whenever a cyanide is reduced, it goes to CH2NH2. So if we were given or think that instead of a cyanide there is a CH2NH2, then what is the molecule we can say? We will say it is RR, OH, CH2NH2. Now whenever this molecule is given to you, all you need to do is do a functional group interconversion and take this unit to CN, and then the rest of the things follow. So that way one can think not only the disconnection of a cyanohydrin but also that of a hydroxyamine. Okay, so that is how one can do this type of smart work while doing disconnection. Let us consider a analysis now. Okay, so suppose the target material given out here, let's call this as, in this lecture, this is 1. So as I have discussed, we will do to convert a CH2NH2 into a cyanide, and for that we are doing functional group internal conversion, functional group interconversion, and then let's disconnect using the 1,1 DIX. What do we have as synthons? Plus plus out here, OH minus and CN minus out here. So for that you want to get the starting materials. Obviously it is going to be H2O and HCN, and that we generate by adding the protons, and for the neutralizing this particular synthon we will add a O2 minus. So what do we get? We get this. Alright. So now while synthesizing this molecule, what do we say? We have a cyclohexanone. We are using KCN in presence of ethanol. So this is 1,2 nucleophilic addition reaction, isn't it? Alright. And then we get out here the cyanohydrin, which can be further reduced using Adams catalyst. Which is hydrogen in presence of platinum oxide, and we get the corresponding hydroxyamine. Similarly, we can use this for disconnection of alpha amino acids, which we'll be taking in the next lecture. Thanks for listening. Have a great day.